And welcome to today's stream. As the stream title suggests, we're going to be using Fusion 360, designing a little dog palace. We did come up with this design a few streams ago to fit in a. At that time, we didn't know what size bed, so we just kind of made it with some assumptions in mind. But with that said, we are going to make some more variations on this and probably incorporate the cat condo design that you can see here in the kind of featured image on that page with a slatted wall and the feet raising off the ground. I'm going to try and combine some of the elements from both of those. Maybe replace the top with a slatted roof and maybe have like a wraparound series of slats if we can do that. I've also been advised that this design might not work the best because the dog is like 4 pounds, so it's like a little tiny kind of Yorkie. So the height of this in combination with a raised bed as well, those together are going to be a little problematic for the pup to jump into. So I'm thinking we can kind of work on having a wraparound slat wall and kind of keep this nice and closed space for the bed, but also potentially work on having a deck out front that'll serve as a kind of an intermediary step for that dog to get onto there and then onto the added space that would be the cushion. Because right now it's it's it'd have a cushion in there, kind of something like that. Obviously not that sticking out the front, but you get the idea. So the cushion in there would be an even higher problem for the dog trying to get in, because it's 5 inches. 0.5. 5. So yeah, 5-inch bed in there is going to be, whatever height we've got here, which is I think 1.5 inches and another inch, so like 2, 3, almost 8 inches from floor to jump height. And when you're a little dog, I think that is a big ask. So with that in mind, we will go from here. That design is kind of something good to just bear in mind, so we're going to keep it up here. But we're going to kind of start anew with a new design. Keep this one open as well, actually, just so we can flick back and forth. So have that one there, new design. And then we'll save this one as Palace. So we can kind of go between the two. Okay, so Palace. So I think if we kind of sketch it out from above, we had the right idea with this one. It had a little kind of plinth underneath that makes it look like it's floating. Kind of gives it that airy look with an otherwise boxy shape. So we'll start off here. In fact, before we even start off there, we're going to make some parameters. So we know the dog bed is bed width and that is actually 24 or maybe 25. Let me just double check on that. I think it's 25 actually. Yeah, 25 by 25 by 5. So 25 inches, and then bed height is 5. So we have that as our guideline, and we can use that as kind of jumping off point. Thanks. So we need to have the outside width be whatever thickness on either side, because we want the bed to kind of fit in there pretty snug so it's not sliding around. And because it's a fabric bed, it can, if we get the measurement off by like a 1/4 inch, 1/2 inch, it'll just kind of squish nicely. So we need to raise it off the ground as well. So let's give it that 1 inch reveal. So reveal is going to be 1 inch. And then our thickness of material, we're going to be using thick ply. The ply is going to be 18 millimeters. Could probably go a bit thinner, like maybe 12 millimeter ply, 1/2 inch. But we'll start off with 18. We can always change these parameters around afterwards. So what else? We have the thickness of the wood, the height off the ground, the width of the bed. So I think that's all we kind of need to get started. Oh, we need a dowel as well, because we're going to use a slat wall. So our dowel is going to be a... Let's have a think now. Pull up my trusty oversized ruler. Probably like 1/2 inch is going to be thick enough. So if we do a 1/2 inch dowel, that'll be good. Then the slats themselves, we can either use plywood or solid wood. Solid wood's going to give it a little bit of a nice variation, I think, without having to use any extra paint or anything like that. It's going to give it a bit of color variation. So we will probably use some solid wood. So maple width, and that's going to be probably sort of a 1/2 inch in the middle. And make sure we have enough kind of bulk around that dowel so it's supported. So we need at least 50% of the wood to be in place. So 1 inch plus. We could probably just go for 1.5 inches, because you can buy that pretty easily. Standard dimension 1x2 lumber. And maple thick is, we'll do thick maple to keep our, no, we'll do it this way. So we're typing maple. Maple thick with the correct spellings. It's going to be 0.75 inches, a true 3/4 when you buy 1x4, 1x2, sorry. And here we will need to think about the the plinth underneath, how much that's going to be taken up. So we will do, we already have the reveal height, so the reveal, the plinth. We're going to do reveal plus, so it's nice that we can reference our existing parameters here. So we can do reveal plus, and then give it, basically telling it how far above the floor. Realistically, we only really need this to be the same height as the reveal, but if we want to have any overhang, this is going to have to account for that. You'll see what I mean in a moment. So we're going to do, we'll actually make a different measurement first and call that side drop, and we'll have that be a fixed value of like 3/4 of an inch. We'll actually give that comics as kind of not a very descriptive name. Amount the sides hang below the base. So then what we can actually do is do a plinth and then do reveal plus the drop, and it will automatically calculate. So if we change the size of the reveal, this will automatically update, and the size of the drop beneath the base. So that'll keep it all kind of neat and tidy. We might also want to expand this a little from just 3/4 of an inch to a bit more. 3/4 should be fine. I'm thinking that we're going to be able to use some wood screws or similar just through the sides. Maybe pocket screws on the insides, but basically you want to be able to get in there with the screwdriver and be able to fix those in place. So for now that should be good. So we're going to create a rectangle, and we're going to make that be our bed width. Make sure we're going from the top, and then bed width, because it's a square. So bed width by bed width. So that's going to be our kind of inside, I'd call it a bedroom. So this hollow that we have here. And you might be noticing now this is the design we're creating is square, and this one's kind of rectangular, and we're going to use that to our advantage. So whereas in here we have a lot of faces, only a 14-inch gap there. It's pretty much going to be extended out, so we're going to have the same kind of profile look to it, but what we're going to be able to do is extend one end to have a overhang, like a slat wall overhang, have that end be open for the dog to come in, and kind of add a little deck type structure. I'm going to sketch that out here just to give a bit of a better idea of what's going on there. So side here, we're going to say our right hand side, as we're looking at it, is going to be, sorry, the camera's always flipped, so that looks like left to you, but that's my right. So our right hand side is going to be the deck side. So we'll say that this needs to be our ply thickness, because the little wall, and we can make that be aligned in this corner here. So you see how all the lines have turned black now, whereas previously it was blue. Blue means we can drag it around, and if we lock those in place with a coincident, black means that they can no longer be moved around, as you can see. So we're going to do the same thing on the other side, like so, And you see that time I didn't type in the dimension, but we can just press D for dimension and drag it up here, and that's going to be our ply as well. And then we'll copy that little trick with the constraint down here to make sure we have the sketch point. You see how when I hover over them, I'm getting this little menu here by holding down left click, and it kind of selects everything in that. If you were to shoot a ray from your mouse, it kind of selects everything that would be hit by that. So as I hover over this top one, you can see it's kind of just a sketch point, but we want to use the sketch point that's connected to these two lines here. So when they go blue, that's the one that we want. Because they're going to be connected to the actual rectangle we've drawn instead of the origin. So if I can, it's going to always just be small, but this little purple dot with the little grey dot around it, that's the origin. So if I were to, let's see, I think it's this one, if I had to delete that, I can move everything around. You see we have the little purple dot still there. So everything's turned blue now because it's not, they're not editable in the sense that you could change the shape, but they are editable in the sense that we can move it around freely. So we just need to bear that in mind with what we're doing. I like to just, kind of parent it to the origin so that I know when all the lines turn black, there's no risk of it accidentally shifting shape. So it just kind of confirms to me that they're all locked in place. So I'm going to save that, and just to get a preview over here. And luckily it's given us a little 3D preview. You can kind of see side by side in this top left that it's it's taking up a similar footprint, but the shape is different. So what we can do, now that we kind of have this side wall in place, we need to put the back and the front on. So we'll do just the same again with a rectangle coming over here with the ply thickness and to wherever, and then we can use a different constraint this time, where we say we want the entire line here, the little blue line. We can say using a collinear constraint that we want it to be lined up to the edge here, and that's kind of similar to what we did with the coincident constraint. But if you have something that is not touching, you can use collinear as a way to have those two lines line up in the same plane. So you might get them parallel, but they'll still be off like that. But if you want them to be lined up in the same axes, then they have to be using a collinear constraint. So we'll just again repeat that up top from here to around here. Again, D for dimension. This edge here is going to be our ply again, and a collinear constraint from here to here. So essentially what we've kind of sketched out here would be a box. So that's good. We're going to need to come off of this, like I was calling it, like the deck side. So I'm going to go back into my sketch here by double-clicking on it at the bottom. And I'm just going to go in and out of sketches by doing Finish Sketch or rotating the view cube up here. I like to use Finish Sketch though because it brings me back into perspective view rather than orthographic. So I'm going to zoom in over here so we can focus on what we're doing with the edges. And so here we kind of need to think about how we're going to do this. So I think a good option would be for the frame as it is to sit in place. And then, or maybe not. Basically, we're trying to figure out how we can combine this cat condo with this dog bed. So I think we want to take the slat wall that we have here and kind of extend that out as a kind of like a shade over the deck type structure. Over the deck type structure in this direction. Still getting used to the camera being flipped. So out over here. So let's draw a rough rectangle to start. And I think what we'll end up doing is if we were to look from the front, this side here, where the dotted blue line is, would actually be an extension of that plywood, so we'd get a kind of like wraparound effect. So it's a continuation of the front wall. I just kind of sketch it out roughly here. You'd be looking at the side view, something like this, with a little kind of, I guess you could almost think of it as a fence, like that. So if you're looking from the side, we'd be going for that kind of look, but maybe bring this down towards an angle like that, with the slat wall kind of going up above like that. Little gaps that way. And we could continue this up towards the back corner maybe. And this is just kind of how my design process usually goes, with a kind of figuring out as we go. So let's kind of bear that in mind. Yep, so that's going to be from there. So we're going to keep the deck size inside of those external front and back walls. And we can just kind of go for, like I said, it's a small dog this is going to be designed for, or just kind of think about the rough size of a step in your home or on the streets. They're usually, not much deeper than 8 inches, 6 inches maybe. Since it's a pet step, they kind of have a bit of a better time using a step. They don't have long feet like humans do, so it only really needs to be like maybe 6 inches. So let's do that, 6 inches. And we will use a collinear constraint again, so we can get it lined up to the inside. Lined up to the inside of that one there. You can see I use that technique again where you hover over and hold down left click so you can select which line it is that you want to be going for. So top one is the long one, middle one is the short one, and the bottom one is this entire profile. Don't know if that translates well on stream. You can kind of see very faintly the bottom one changes colour. So we would continue to get these edges out to the side. So whereas this here is connected over in this corner. Nope. We can also just draw a second rectangle to kind of get it in place there. So let's do that from the front to there and from the top to this corner. And because we're using directly to the existing points, because we're going directly to the existing points, it's already creating those constraints for us automatically. So we're going to hide some of these dimensions now, just to kind of clean things up, because we have our dimensions kind of fixed in place now. We don't really need to see them. That said, I think I do want this maybe just to be visually a bit longer, because right now it's kind of pretty much like 25 inches by 30, so it's kind of a bit squat still. So here you can see we have a new parameter in Palace, sketch 1. So we're looking here for anything that isn't using our preset parameters. So here, linear dimension 8, that's the one we use for the depth of the rectangle. We're going to actually create a new dimension and call that deck depth. And we're going to say we actually want that to be maybe like 9 inches. And then what we can do here is, where it says 6 inches here, we can actually change that to be deck depth. And when we click OK, it's going to stretch that out for us. That's one of the things that I really love about using parameters over hard coding the numbers in. So I think what we can do here is, since we're going to have the slat wall going front to back this way, well, yeah, the slats are going to be going front to back, with the dowels going left to right. We're going to need some kind of fixture going to finish the sketch up. Maybe we should start doing some extrusions as well, so we can kind of figure out what we're working with in 3D. So before that, let's kind of get the plinth laid out, so we don't forget, or so I don't forget. So we want this chain here. And these two, and these two. I'm going to drag those inwards so we get an offset plinth. So our plinth, we want it to be flipped, because it's going the wrong way. So that's going to give us the same gap here as we're going to use vertically, just it should be enough to keep it hidden. So we're just going to use that there, and then we're going to do the same thing again. We can't use that, we have to use the initial offsets again. So that one and that one. We're going to do our plinth flipped again, but we don't want it on exactly the same. We're going to do the negative of a combination of plinth plus thick ply. And what that's going to do is give us an offset that is the thickness of ply inwards from the one we already have. Okay. And then we can just kind of sketch these lines out as they would be. So just kind of zoom in, get in flush. We could kind of make it idiot-proof as well by, instead of having 2 longer sides and 2 shorter sides, we could have it be kind of like a rotating pattern like that, so that there's always a end piece going into a long piece. I think we'll just kind of pre-assemble that. So we just kind of send it as one big base. So with that done, we can then actually, thinking about it, that's not what we want to do at all. So let's delete these 2 lines and make these into rectangles. What we really need to do is have this extend through to the bottom there and support the deck, otherwise it'll start to bow over time, which obviously no good. And we can actually use collinear again to make sure that the front of these 2 lines up. So collinear, we're going to select that one first, and it kind of flips into place. Now when I move one, both of them move. We're going to use dimensions from the outside there and have our plinth measurement. Actually, let's show our dimensions again and change that to be plinth plus ply. Plinth plus ply. Because we're going to put a little front in this as well. So we'll probably put a stretcher in the middle as well to support the weight. I mean, it's a small dog, but if this was bought for a larger dog, maybe this would be useful. So let's get our rectangle again. We're going to go from here to here, making sure that our ply is the thickness between the 2, and then we're going to just click on that blue line to make sure it's connected. You see it all turns black. Now we can drag this one up and down, which is not what we want. We want to make sure that all of these are the thickness of ply apart. And the reason that these have kind of become mobile again, even though they were previously locked into place, is just because when we deleted those 2 ends, it was no longer a rectangle. It wasn't really fixed in place anymore. So we're just going to have to go back through and make sure all of those are locked down again. And once I do this to this edge, it should be all set. Yeah. This here is wrong. We should delete that. And this line here actually should be connected to the end. So we can connect it to this and say that these weird lines that we have, these should be connected in there. And we can actually just do a copy of this rectangle that we have. So we can double click it and select any edges that weren't by pressing Command or Control or even Shift and selecting those. Do copy, paste, and things kind of in the way a little there, so let's close that out. But we'll just kind of drag that out to roughly somewhere. We'll even put it offset like that and say OK, and bring back our sketch palette. So now this is kind of free floating. It's, you know, it's a bit weird. We can use a midpoint on this line here, a little line, and then this larger line here. And again, I just realized we have a similar problem up top. So I'm going to delete that and connect it to that. Connect that to the outside there. So you can see how this one moves along with it. And now the only way to move this is up and down, so we can do the same thing, a midpoint. And what that does is takes the midpoint of the line and locks it to another point here. I'll do that and I'll say error because it's already constrained by these vertical constraints. So we can use midpoint here to midpoint on this line, and it basically centers that between the 2. So with that done, we kind of have a strong base for the palace, and we can do a save there. So we have like the top-down kind of plan view, if you will. We could also maybe add a front onto here. because right now it's looking a bit bare bones. So we'll just do like so with ply again there and connect it up there. And basically that front is just going to be able to hang down so that it doesn't have a weird kind of float compared to the rest of it. So we're going to create a new component, and I always work with components because that's just a better way to do it in my opinion. You can kind of move them. Any parts that are the same will kind of respect that when they are changed. So if I change the length of this side would change as well. So I'm going to call this plinth, and it's automatically activated. If it's not, click the little dot. We're going to go E for extrude, and just kind of select all these little lines that would make up the long sides of that plinth, but just one of them. So just this long side here. I'm going to do a new component again with a height of plinth. Not sure what went wrong there. Let's try that again. Height of plinth. And it's going to be a new component. And because we have this one activated, it's going to be a new component inside of this component. So the same way you'd use folders for your desktop, you can have a folder inside of a folder. Just kind of a similar thing, components inside of components. So we do that, and if your sketches disappear, there's a setting up and preferences, and it's pretty much what you'd expect under design. It's auto hide sketch. I turn that off because often I use one sketch to lay out the whole design. So yeah, in here we have component that was just created. That's going to be our plinth long side. And we are going to just stay activated in the main component there, and we're going to select the long side and copy paste that, and then we'll use point to point here to go from this edge to that corner. And what that's letting us do there is just move it to where our sketch lines are. So we'll do a extrude again. You can see up here they actually have the numbers, so the first one, the second one. That's going to be a new component again, using this one, and then we can just click on the top of this and it'll be the same height. So we're just going to type in plinth though, because you saw how it had a number. We don't want it to have a number, we want it to have a parameter. So we have plinth there, and say OK to that, and rename this to be plinth short side. And I don't even think this is called a plinth, really, but it's what I've always called it, so if it ain't broke. So we're going to get this one, we're going to do copy paste, and same again, we're just going to use our point from this inside corner here, and just kind of transfer it to that. And we're going to do the same again, paste, and the point from the inside corner again to the outside corner over here. And now I have a good layout for a base to support the weight of this bed and kind of aid in that floating look. So we can close out that, go back into the main palace component, and what we can actually do here is start to think about how tall we want these sides to be. So we know we want the base obviously to start on top of the plinth. So the easiest place to start is probably going to be the base. So if we do a continuous surface front to back, we could use just one sheet of board. I think that's going to be fine, since we are going to have this length on the side anyway, so it's not like I'm going to save any space in shipping by not having it go the full length. If it was a different case where you'd have the deck be a separate part, it would make sense not to use, obviously, the full length, but we will. And I'm going to hide the plinth here using the little eye so I can access all these little parts a bit easier. And I'm just going to select everything that would make up that surface. So all of these little squares, rectangles parts, like so. And it's looking good. Yep, it's looking good. Nice. So then we'll do our apply thickness, but we obviously, if we had it there, you can see it's intersecting. If I check the intersect option, you can again see it's chopping into the base. So what we need to do as a new component is you do it like that, and it's just going to be visually intersecting, as its own thing. But what we can do is, instead of profile plane, which is the plane that sketch profile exists on, we can do from an object, and that object is going to be the top of that plinth. So we're going to extrude by the thickness, but we're only going to start that extrusion from the top of the plinth. So we have the base already raised up for us. I'm going to rename that to just be the floor. Well, no, the base. Base makes more sense. Cool. So I'm going to hide the sketch and kind of see what we have here. You can see where we get that kind of floating appearance. That's going to become more exaggerated when we add into it the overhang here on the edges. So I bring back that sketch. I'm going to hide the plinth, hide the base, and I'm going to start to think about which pieces actually need to be around the outside and how tall they need to be. So this is going to be a component for each part, and that component is going to be the, let's say, the deck facade. Let's activate that. It's going to be this little front piece here that we accounted for. So in the same way that we don't want this to start directly on the floor like it is, we want to be offset from the floor, and the height that we want to be offset by is the reveal that we used in our parameters at the start. So right now it doesn't look like much, so I'm going to actually switch this back to profile and say we'll go for a distance of, like, say 3 maybe. So here, if I go back to offset and I say we want that to be offset by the reveal, see it raises it up. If I bring back the base and the plinth, and we'll just say OK for now to that, and then go back into the activate component at the top. See what that's kind of looking like. We have that little overhang at the bottom. It's going to help to shield the view from the plinth that's down there, hopefully giving it that floating look. I think it's going to be fine, because that's 1 inch. It's going to be on carpet or a rug. Even on solid floor, it shouldn't be too visible. And once you have all the sides around, I think if you look at it from over here, unless you're laying down on the floor, you know, that's pretty hidden. So you might have noticed that we did a solid dimension for the height there. So that tells us that because we had to hide these sketch dimensions, because we had to type in a dimension for the deck facade height, let's pull that down. It's going to be in the extrusion here, and you can see that's here, a long distance. So because we had to type in a solid dimension there, we want to be able to convert that into a either into a combination of the parameters that we have above, its own parameter, or have it go to the top surface here instead. And I think the best option for that is probably just have it to go to the top surface. So we can look down here in our timeline, and you see the last thing we did was the extrude. You can actually name these as well if you want. I never really do, I just kind of hover over them, and the part that it's affecting is highlighted. So I'm going to double click on the part on the history where the extrusion was applied, there, and instead of distance for the extent of the extrusion, we're going to choose to object, and the object that we're going to select is the top face of this, and we're going to say OK to that. Now you can see that's flush with the top. So that'll be just a nice little flush surface. We'll probably end up just putting like a little bit of edge banding or something on there to account for that. So bring back our sketches and hide them. I'm going to do a similar thing again for the sides. Although the front and back, I think we are just going to use as layouts, because we were talking about doing that little kind of triangle shape from the front of the deck up towards, the back being flush. So if we're going to have an overhang here front to back, we're going to need something to support that overhang top to bottom. So in order to have that, I think we either need to have a little kind of couple of pillars on the front, or have the front face of the deck area kind of supporting that, so kind of almost like a wall with a doorway in it. Let me see if I can get an example of that, like a enclosed porch, something along, like a. See how this one is kind of enclosed with a pillar supporting the overhanging roof. So maybe something like that, but less ornate. Just something to hold up the wall that's going to be in there. So I guess in order to kind of figure out what we need to do for that, let's first off get that wall in place. Then we can kind of figure out where we actually need support on these side, back, front walls. So we're going to do a new sketch. That sketch is going to be on this. We're actually going to base it on this front plane here, or maybe no. We'll just do it on that face at the back. So getting like the front view of what you kind of call a porch, I guess. So from here, we're just going to say we're going to have a circle up top with a diameter of dowel, because we kind of have that set up, and we can just copy paste that. And I'm kind of being sloppy on purpose. What we can do is use a horizontal vertical here to say we want this one to be horizontally aligned to that. You can see this one popped up into place. So if I undo it and zoom in a bit, So this one is going to be horizontally aligned to this one. And what you can also kind of think about there is, if I undo that, if we were to move this circle past 45 degrees, so 45 degrees here would be, you know, around there. So because that's past 45 degrees, what's going to happen when I do the horizontal vertical is it should go as a vertical constraint. So that's just something to bear in mind. It's kind of like a 2-in-1 constraint option. And then I think what we can do here is, we know that we want the dowels to be on the inside of those walls. We don't want the slat wall to be poking out the sides too far. You know, it could come flush with the edges, but we don't want it to be extending out beyond that too far. So we would have to space these apart appropriately, because you want to move one up and down, the other one moves too. So what we can do is space those out like so, and say that we want a dimension between them. It's going to go for the centers. We want that dimension to be the bed width, but we don't want it to be the full bed width. We want it to be bed width minus maybe like the thickness of the maple, maybe. It's like maple or maple width. Basically, we don't want them right by the edges of the maple, because then it will not provide much real support for them. We want to be inset a little. So you see that when I hit enter, it kind of made them like that. It's going to be on the inside of that bed. We could probably even afford to go a little further. So we could do, rather than maple width, maybe reuse our plinth. So it's not that much different. Maybe a combination of the bed width, but take away 2 of the plinth width, so 2 times plinth. There we go. And then we can just space these out from the outside by measurement of 1 plinth. So we do the same there. We'd click on the circle, click on the edge here, and kind of drag upwards, because there's a couple of ways you can dimension it. The absolute distance, vertical distance, horizontal distance. We want the horizontal. I'm going to do plinth because we did 2 times plinth, so it means it's centered. So with that done, we can also start to think about how high we want those to be. I'm going to hide the dimensions here again. So how high do we want these to be up and down? You can see they're kind of locked in side to side, and they're in line with each other. So you need to think about what is the ultimate height of that roof. So we can think top of the roof, bottom of the roof, or center of the dowels. So I'm going to draw the rectangle of what will be the maple boards around them. I have construction on, so I'm going to switch that by double clicking it, pressing X. So it'll be something along those lines. And we can actually bring back dimensions. What we can do here is, if we have the size of this board here be the same as the bed width, side to side, and then say that outside of this one is 1 plinth away. It's going to keep that aligned, you see, to the edges. There's a couple of ways we could do that as well. We could use a collinear. As long as everything's referencing the same parameters and it's all kind of locked together, it's fine. So the only thing that can be moved around now is the kind of height of this, which we already know top to bottom is going to be our maple width, because it's kind of the sideways version. So still move the whole thing up and down, but it's as one unit. And we can either center this with a construction line, or we can just say that we want this one to be away from here by maple width divided by 2. So it's going to be halfway through. And then all of them should move as one unit. So the kind of holes, the dowels, and the maple are moving as one unit. And now we have a bunch of options that we can choose to either go from the top, the bottom, or the center of that dowel. To measure from, I'm going to hide the deck facade, just to get an idea of the actual base height. So, I'm going to hide those dimensions again so we're working a bit more cleanly. The way I think I want to do it is we're going to go for an amount of space, basically. So the top here realistically needs to have a big enough gap so the dog can get into the top of the bed. That's going to be like here. So let's kind of select all that, make it a construction by double clicking it, pressing X, and we will constrain this to the top face there. And we'll say the height of this is bed height. So realistically, we need a big enough gap here that the dog can easily get in and out. So I'm going to measure from the top of this. I'm also going to just fill this in just because it's going to be bed width. And we'll go to that corner. So we're going to dimension this from the top of this, ghost bed to the bottom of this slat here. And we're going to say that dog is going to need at least, let's call it the ruler. I think 12 inches should be good. That's like about that. Yeah, it's basically, one of these kind of, like a nice sort of folder size, A4 letter size piece of paper in height, enough of a gap for it to get in. So we'll say we want that to be 12, and because that was a solid number, instead of a parameter, we're going to come into our sketch 2 that we're using, find it down here, 12, and we're going to make a parameter for that. That's going to be entrance height. And they need to be capitalized, nothing else is. I'm going to say 12 inches for that. We're going to come down here, change that to the entrance height, say OK. It doesn't really do anything to our drawing, but it does mean that our dimensions are now parameters rather than just numbers. Because imagine if we scaled this up and we needed to make it for a Great Dane. If we had a 12-inch height there, it's going to be a bit of a squeeze for the dog. Whereas if we have entrance height, we can change it in one place, and then we should be able to update this throughout the whole file. So we have there. We have the bed kind of floating off to the side. We look from above with orthographic view. That line is on the outside there. We don't really want it on the outside. We want it to be lined up with the inside of this here. So when we create the extrusions for these, we're going to be ensuring that the extrusions start from the inside edge, not the outside. We will need to extrude into the back edge a little, just to make sure that the dowels have somewhere to go and they're not just floating freely. because that won't work. But as it stands, I think that's pretty good. So we can now think about this back wall. Since we have the slat wall height in place, the roof height, so it's going to be 12 inches of room for them to kind of crawl around in. Looking at it, it looks a little squat, so I think what we can do with that entrance height there is make like 15. That's a bit more in proportion, I think. Yeah. Yeah, that's a bit better. Might even be a bit high. We can always bring it down afterwards. Because in the end we have 5 plus 15 is 20, plus the height there is like 1.5 inches, and then the height of the plinth and the board again is like 1.5 inches there and 3/4. So ultimately it's, you know, almost 22 feet tall, like 24 inches. So if we measure from this point here to that point up top, yep, do XYZ delta, it's like almost 24 inches. So let's think about that in terms of parameters here for the back edge. So we're going to want to create a parameter. I know that much. Anyone watching that knows me knows that I like those. Let's call this the back wall. Back wall height. So the height, we're going to eliminate the reveal. So whatever the height's going to be is, you know, we're going to minus the reveal off the end. So we may as well do that now, so minus reveal, and then come back to the start there, and oops, let's edit that again. So the reveal, we're going to do, keep hitting entrance as space. So space out a bit. So whatever is in these parentheses minus the reveal. So we want to have the maple width plus the entrance height plus the bed height plus the ply thickness of the base and plus the spaces. I prefer when they're spaced, easier to see. Plus the overhang at the bottom, which, what do we call that? It was like the side drop. And if we hit enter, it's going to evaluate and tell us that that's a almost 22-inch height. You see that in the value. So what we can do then is, well, this is capitalized, I don't like that. We can take this back wall here and say that we want to do a offset start, and the offset is going to be, again, by the reveal. And the distance that we're going to do is our back wall height. And I'm going to make a new component, and something here is ms. What have I forgotten? So the side drop, thickness, bed height, entrance height. I think I used maple thick instead of maple height. So I'm going to click OK, I'm going to check that over. So in here, maple width, entrance height, bed height, thickness of apply, side drop minus the reveal. Oh, so because we're starting out we're adding the reveal, so we don't need to minus that. So we're just going to remove that and then come up to the top. Super. Yep, that's good. So that comes up to the top there. It's its own component. We will bring back the deck facade and rename this one to be back wall. And maybe we want to get a little fancy with this, put some. No, I think we just want to leave that as a whole, a big flat board. Yeah, that seems fine. So if I hide this back where you can see this is still in place, so we're good there. What else we want to do is get these sidewalls going, but we need to think about the profile of that shape that we're going to be incorporating. So like I said, we want to have something on the fronts here. So I think we're just probably going to have something that comes up by like an inch or so, maybe 2. Let's have it come up by the reveal height on the top. So the reveal there, and then also, so we're going to come in from this front face here. So when we're sketching, we can delete that because we don't want that. It automatically projects some of the lines in for us. So this had made a rectangle there, so I'm just going to double click those edges, delete. And delete these projected dots as well. And that should be good. Basically what we want to do is just say, I want to go from this dot here, so I'm pressing P for project, and it's going to project the geometry that we have into the scene. So P to project that, P to project this top dot there, and then want this bottom side here as well. So basically the 4 corners that kind of make up the ghost of the frame. We're going to want the top corner of this as well. This one as well, because there we might want to kind of come out a little further, but we'll see. That should be good for the projections for now. So then we're going to use our line tool, and using that line tool is going to come up off of here. See, it's already trying to create that vertical constraint for us. We're going to come up by reveal distance. Cool. And we're going to do a rectangle from this corner to, rectangle, R for rectangle, from this corner at the back to this one up top. And we're going to make that line there a construction line, because it's only going to be one face in the end. So we have the sort of line here. I'm going to actually hide the base as well. Kind of want to be able to see these lines here. So I just changed the view to the top view. We're still in the same sketch. And what we can do is just project in this line here into the scene, and this one as well. I don't know if you can see it, but it made 2 little purple dots here because it's projecting those lines into 2D space, so it's kind of just doing so like that. So it's an infinitely small point, which is good, it's fine. So I'm going to go back to the view that we had on the side, zoom out a little so we can see what's going on. And you see we have those 2 dots there, and we can use those as reference to get things lined up. For where this starts going up, and then maybe we want to go on a bit sharper angle, because we're going to have a little retaining part here for the bed to sit in. So, in fact, I'm going to undo that. Just those. Finish the sketch, and what I'm going to do is just create that little retaining partition before we go any further. So I'm going to E for extrude again, get that profile, this profile, that profile, and these 2 at the inside over here. And we're going to go as a new component, and it's going to be from the top surface of this base here. and the distance is going to be, let's see, bed height we could do. So 5 inches is about that. I think it'll be fine for it to kind of jump up onto. Should be fine like that, I think. And so if that's the bed height, we should be good there. Click OK. And we'll just call this our divider. Okay, and then we're going to go back into that sketch that we're actually going to drag the sketch from the timeline to the end, to that. So you can drag these around in order. So we're going to go back into sketch now, and now we can project these 2 top points into the line, because we're going to use those as part of our guide for what we're doing. So we want to go a solid line from the top corner to this one here, and then to this corner, to this one, and then to the top there. So we get a good angle there, and then the back side as well, down, all the way down to where the outside would be. And you can see it turn blue as a finish shape. And then what we can actually do is extrude this outwards as a new component. Extrude that outwards by the thickness of ply, and that should be good. Should be good. And we'll just call that our sloped side. Okay, and hide those sketches so you get a better idea of what's going on here. And I think we're looking good. I think one of the things we might want to do here though is this little notch. I'm not sure if I'm keen on that. We might want to just lower the height of this by a reveal dimension. So we're going to take the top of that and do negative reveal. And that should help as well with the, you know, the hopping over. And that's a little better in my mind. We can work with that a bit better. So we're going to take the slope side here, we're going to copy paste it, and what we're going to do is a point to point from this back outside edge to this inside edge here, and say okay to that. Now we have a little nook for them to hide in. Like on its own, this would be pretty good in my opinion, but I think once we can work on adding the slat wall roof to it, it's going to look even better. So sketches, I'm going to hide sketch 1 and 3. So we just have the slat wall sketch. And I think what we can do is take the profile of that and say we're going to go from the inside object with an extra offset of, let's say, 1 inch from the edge. So new component there, and we're going to extend by our maple thickness. Okay. Pretty good. And that's a new component in itself. I'm actually going to undo that because we want to create a new component first before we even take that step. So, new component first. We'll call this the slat roof. Activate that, and then we can do our extrusion on in the same manner again. So, from this object on the inside, a depth of what do we say? It's going to be off of this edge here by the reveal. Yeah. And then it's going to be, wait, no, the distance that it's off there is going to be reveal. And then the distance that it's extruded by is the thickness of maple thick. And I actually made a body, should have been a component. But we can fix that just by right clicking here and create component from body. I'm just going to call this a slat. This is one way to do it, but when it comes to the render, it's not as good because now this is going to be identical on every single one. So what we can actually do is undo that and leave it as a body instead of a component. I don't really like to do that, but well, I'm kind of agonizing over it. Let's leave it. Leave it for now. And maybe we can just change the texture coordinates as a whole rather than individually. You'll see when we come to it, it's going to be a little weird looking. So we can hide that sketch now. But what we can also do is this slat here, we can do a copy paste. Undo that actually, don't want that. So we're going to copy the slat first, activate the slat roof, and then do a, again, we don't want to do that. We want to activate the slat roof, and then we want to select the slat itself and say create a pattern on a path of components, yes. And the path that we're going to take is going to be this little tiny short edge that's in line there. I'm going to say we want to go by spacing, and the spacing that we want to go by is maple thickness plus reveal. So now they're all going to be spaced an inch apart. And just keep upping the quantity until it looks good. We actually want to do reveal. Yeah, I like it as it is, I guess. So I'm going to go from the top, just so we can get a good idea of when we actually kind of hit the limit, which is going to be there on the inside, you see. If we go one more, it's going to be too many. We could also make a parameter here, and we'll use a no units parameter. That's going to be slat number, and we could say that we want that to be we want that to end up being the maple thickness plus reveal, because it's going to be spacing. Multiplied by like that. So that's going to be one section of it, and we want to divide the main width of the base. So we have the bed width plus the deck depth plus the thickness of that little divider in between, so the ply. So that's one portion of it, and then if we do a divide that, we get 19.8335, which obviously is not a solid number, so we need to do a seal operation there. Oh no, sorry, a floor of the entire thing. So we're doing floor of the length that it needs to go divided by the thickness of the spacings, and it gives us a total of 19. And this is kind of, you can use all kinds of different great mathematical operations inside of Fusion for that kind of thing. But the nice thing about that is we can put that into the pattern here. So instead of quantity, we're going to say slat number and hit enter. And then what that does is if we were to change any of those, so if we were to change any of those from let's see, if we were to change the bed width, let's say. So what's that? From 25 inches to 20. You see it reduces those in number. So now there's only 16 of them. So if I put that back up to 25, it brings in the appropriate amount. Something else you may have noticed then is when we did that, because these are moved into place based on the sketch, they are actually not staying where they should be. So just going to change that back to 25. We could fix that later on with some joint constraints, and they should stay in place a bit better. So let's kind of hide that, hide all the parts of the slat roof, and activate the main component. So this is looking pretty nice, I think. Looking pretty good. Obviously, as it is, it's going to sag. So we need to think about what we're doing in terms of supporting this on the front edge. So we could have a transitional piece here that would be a bit thicker, and we could do a dowel into the bottom and kind of come down that way and just have dowels supporting it, little pillars. Alternatively, we could do another kind of slat wall on the front, and we could tie it in that way. I kind of like that idea as well, although I do also want to see what it would look like with a wraparound. I actually think it would look that good if we did a wraparound slat wall on the back instead. So I'm going to keep it as it is like that and do something to support it on the front. And I think that something is going to be making the transition here. Try and do it in a way where I can see what's going on. Sketches, sketch 1. So from the top, it's not kind of hard to see. If I hide the slat roof, what we're looking at. Okay. And then the sketch is the final part there. Okay, so we have the deck facade on the front, and the slat wall comes to there. So I think what we could do is have this front piece actually be a little wider, but you see if I was to extrude this, they're all going to change. It's no good. So I think maybe we could try to it's no real good way to do this. Trying to maintain editability, not sure if that's a word, is going to be difficult here. I think what we could actually do though is create a little channel. So create a separate little kind of slat wall on the front. Let's bring back that deck facade. We're going to create a new slat wall on the front going up in kind of like 2 smaller sections. So it'll be like a little mini one. Kind of supported in a similar way though. And it'll also help us with trying to kind of hide these ply edges if we have a slat on the bottom. So I'm just thinking again though, if we could just have, what's the distance here side to side? 25, right? Yeah. I'm thinking that we could put a bowl or two here. Anyone thoughts on that? That might be something to do. I guess let's get the dowels in place for this slat roof first. So bring back sketch number 2. So we can get those, and let's isolate this and make visible sketch 2. And isolate just kind of hides everything else, because we don't need it to be working with. So we're going to extrude these 2 as a, no, we're going to extrude 1 as a new component, and that new component is going to be a dowel. So I'm going to extrude that, but this is on the back side of the wall, so this back wall here, you see it's on this back face, we want it to be inwards by at least half of that depth. So we're going to do an offset plane inwards by ply thick divided by 2, it's going to be halfway in. And the distance is going to be to object, and that object is, well, let's think about this for a second. That's not going to work for us if we change the number of slats. So the distance is actually going to be slat number multiplied by a combination of reveal and maple thickness. I'll get us to the front, but we need to come out a little more. I think it's going to be that amount as a whole. Plus the reveal that it has to jump initially. And zoom and get a better view here. So it needs to make up for what it's initially been missing, which was the ply thickness divided by 2. So it comes flush there. I think that will be what we want. We want it to be flush with the front. So just say OK to that as a new component. And then in here, rename that to be dowel. And say we're going to copy paste that, and it's going to move from where it is here in the center to this one in the center here. Cool. Let's close that down and isolate so we can get back to what we're doing. Hide that sketch. And back into the main level. So we have the dowels there now. I think what we can do, it's kind of hard to explain, is do a supporting part here that kind of locks into the top of the slat wall. So it's probably easier if I come in from the side here and draw a sketch. And we actually do want this rectangle in place this time, because we're going to use that as a guide. And we're also going to project this guy in to give us some so do that. I'm going to project this in here so we get the bottom edge, so we don't go too high up. And basically we're looking to do a rectangle here to here. And the dimensions for which are going to be the same maple width by maple height. or maple thick. And I think what we can do for that is actually bring this to be in the middle. So if you pull that to the sides, so it's roughly middle. Let's do a line, construction line, and go from the midpoint here to the midpoint there. And we can say that we want that line to be vertical, so we know it's lined up in the center. Say OK to that. And then what we can actually do with that is make a fresh component that would have this extrusion channel in there. And that extrusion, we kind of hold it in place. I actually don't think we need it to be that deep. We just kind of need it to be like halfway through, maybe. So let's go back to the sketch and disconnect it from the line where it is up here. So now we can pull it down a little and say that the distance from the bottom edge there to the top edge there can just be the maple thick divided by 2. So we get halfway in. And with that, we can then extrude this across. I think that's the good choice here. So we can do an extrusion of this, and we're going to say it's going to this edge as a new component. That's going to be our, I'm going to call that one our slat wall support or slat roof support. Slat roof support. And I'm going to make a new component, and that one is going to be our slat wall. Okay, and we can just drag this slat roof support inside of there. And what we can do then is open up sketch 4 again. And we're going to need another version of this that is just, you know, the standard kind of rectangles. So we're going to have our maple thickness by our maple width. And I'm going to align those with a curvilinear constraint on the edges. So curvilinear on these edges here. And the spacing here from this one to this one is going to be reveal. And stay okay on that. And then, if we activate slat wall, we can then extrude this one to here and tell it to be a new component. And this one actually is given as a distance. We actually want it to be a parameter, as always. So it's going to be negative bed width. It's actually going to be the same for this one here. It's going to be negative bed width. Just in case we change that, it's going to update accordingly. So we will have a look here, and we can hide that sketch now. And we're going to need another parameter to be able to figure out what is the distance from here to here, and be able to get those the correct number of copies. So inside slat wall, we're going to activate that. We're going to do a parameter again, and we're going to just press I on our design to measure from the top here to the top of here. And we're going to take that measurement, click it to copy it, and And really, we should have a better option for this. We really want that to be, I think we want to create just a functional parameter here where because we have this reveal height, you know, our entrance height plus the bed height. Yes, entrance height plus bed height. And maybe actually we just want a few of those, so we'll just do bed height divided by the spacing, and what that's going to do for us is, so no units, and we're going to do solid slats wall top number. It's getting kind of long, so let's give it a comment. Number of slats for the front wall in the top solid section. So this expression here is going to be something similar to what we had before. It's going to be the floor of we don't need bed width this time though, we need bed height. Bed height plus bed height plus our existing portion that we already, well, I guess it wouldn't be plus, it would be minus our existing portion that we already did, so that would be reveal for the gap that we already made. And then divided whatever that number is by our maple thickness plus the reveal. And we would end up with 2. Cool. So take away that reveal that we already kind of added up there. Say okay to that. And it's kind of silly to do so just like that, but it's fine. We'll fix it up. So this component is going to be called the solid beam. We need to do a pattern on path again. That component, I'm going to go down that path, and the spacing is going to be maple thick plus reveal, and the number of them is going to be our wall number, slat wall top number. And even though it's only 2, if we were to change like the bed height in here from like 5 inches to like, I don't know, like 22 or 20, it's going to give us a different amount. Weirdly not in the right spots though. There we go. So a bit of a monstrous design, but you kind of get what we're going for there, I think. Problem here being that it's still not quite supported, obviously. It's just more weight for it to be dangling down. So we will do a dowel from the bottom here into these. And then I think just continue the wall down on one side, maybe both sides, with a space in the middle for the entryway. So we'll see what that looks like as a sketch on the front. So here, and we're going to zoom in a little. We don't need that one in place. We just need to be able to draw a construction rectangle from here to here. It's going to be entrance height by deck depth, so we kind of get a consistent spacing there. Entrance height by deck depth, okay. And then this is going to be collineared to this line here. Kind of our construction mode there. So actually going to midpoint it so it stays centered as well. So this line here is going to match the midpoint of that line there. And out of curiosity, I think this line should be 1.125. Something a bit off about that. I think that's the difference in depth between the edge of the dowel there. So it should just be 1 inch, should be the same as reveal. Let's try that. I think it's going to be this edge here to that edge there is going to be 395. Although that doesn't seem right. So that one to that one is let's do dimension. So I'm just curious about why this is looking a bit weird. So this one to this one. Okay, yeah. Yeah, so, and then for it to do from the outside to here. You see that's a 1/8 inch. So just confirm that's where the error is. Either way, I don't think an 1/8 inch is going to make too much of a difference here. We'll just kind of add it to the bottom. So rather than a midpoint, we'll raise this up and we'll say that we have a construction line from this midpoint to this midpoint. And that construction line is vertical, and that construction line is a length the same as this one. That should be good. Cool. And then this here to here should be one, yeah, because that's the same as our reveal dimension. I guess ultimately, rather than letting this be a driving dimension, we can just tell this one to be a driving dimension, and that one is the reveal. Okay. So with that done, you can pull that inside, and we can also start to make these construction as well. These weren't really necessary, they were just for us to kind of get a guide on what was going on. Cool. Yeah, so we have that there. Spaced out, all good. Want to put slats in here. So we're going to draw a rectangle from the top corner of this one as a non-construction line. That rectangle is going to be a depth of our maple thickness, and it's going to come all the way out to here, and we're going to tell it that it's going to be in line with this edge. Okay, and we'll just kind of copy the component over to the other side, I think. So we have like 2 walls. So that should be good for that. Then we're going to create a new component from this. Going to extrude backwards by maple width, so negative, because it's going inwards. And that's going to be a new component. That new component is going to be inside a slat wall, and we're going to call it, what are we going to call it? I guess short slat. Okay, I can hide that in Sketch. And what we can do there is we're going to create the parameter now for this. So we're going to just kind of take all this info here, copy that, and we will make a new one with no units. The expression is going to be the same for now, and we're going to say short slat number. And instead of it being the bed height, is going to be the entrance height. Alright. So it's telling us it's going to give us 8. We're going to trust that for now. Unless there's something that tells us different in a minute. We're going to activate the slat wall, and we're going to create that pattern on the path. And in this case, actually, I think we can do a rectangular pattern. Getting a bit fancy and weird now with it, but rectangular pattern going down by the short slat number at a distance of the reveal plus the thickness. For spacing, sorry, not extent. So distance of the reveal plus maple thick. Okay. And then this one we want 2 copies, but we want them to be spaced out by a spacing of our deck depth in the direction going this way. We could possibly. So directions are going to be down and this direction is going to be a better way to do this. Like select the front face maybe. Let's get our directions settled in first. So those 2. It's going to be this one and that one. And then the object that we're multiplying is that one. Okay. So we need to do, it's going to be plus the deck depth because that's the gap that we have. But we need to figure out what the actual width of these are. So we're going to have to measure first. Say measure Okay, let's get a measurement first on this. So measure that. It's going to be that length there is 8. But we don't use solid numbers, so what we're going to do is get that rectangular pattern tool with the component part. We're going to get those directions in place. 2 in that way, spacing, and the component we're grabbing is this one. The quantity is going to be our short slat number going downwards, and that's going to be a distance of entrance height. Short slat number, and then this one is always going to be 2 because it's kind of like a mirrored entryway. And the distance there is going to be the bed width minus deck depth. See? And number of those is going to be short slat number top to bottom. And distance, sorry, is not that, it's reveal plus maple thickness. Okay, so okay to that. And if we look in the Palace overall file, what do we have? So it looks like we're missing one near the bottom, and we've not come all the way to the outside edge there. So I wonder what the issue for that is. Maybe I just typed something in wrong. So spacing there should be the bed width minus the deck depth, because the deck depth is the gap. So if I just do bed width, it's going to have it go to those outside edges as you'd expect. Excuse me. As you'd expect, it's going to do those. Excuse me. Need a fresh cup of tea. Weird, why won't they show? But basically what I'm trying to say is that we don't need to be touching this edge here, and they're not doing that for whatever reason. I can only assume maybe the starting position of this distance is not quite in place, because really they should be able to come all the way to the outside edge of that. Snap to minus 4, snap to 4. So it's going from the center. So I think that might be part of the issue. So bed width would take it to the outside edge, it looks like. Yeah. So that takes it to where we want it to go. So we need to do bed width minus the actual size of that. So I think what we have to do is go back into our initial sketch, and where this had this is fixed by this width here of the entryway. So I think what we need to actually do is make that maybe equal, or somehow give this the driving dimension instead. So instead of that being deck depth, we could do this to be a driving dimension and tell it that it's actually going to be bed width minus deck depth. And what's that give us? That's halfway. And then if we take this whole thing and divide that by 2, it gives us the same result, but instead it is this part that's driving the width. And you can see that it's all still black lines, so it's all locked down still. So what we can do for this now is use our spacing here. So bed width minus. Well, we need to create a parameter for that actually. So rather than typing it out all weird like we just did in that sketch, sketch number 5, instead of typing it out like this, we need to make a parameter for it. So we'll say short slat length, and that's going to be whatever it was that we just put 1 in there for now. We're going to copy this and paste it into here, and then say that this is going to be short slat length. So it doesn't really change much, but what we can now use that for is in our rectangular pattern. Instead of taking away deck depth, we can do short slat depth length, and that's going to put it in the right place. Oof, what a little brain teaser. So I'm also seeing that we're kind of missing one here at the bottom. I think what we can do to fix that is, because we're adding a basically the number of short slats rounded down and the number of long slats rounded down, what we can actually do instead of floor here is do ceiling, so ceil, and instead of it being like that, still giving us that bottom one up. The ceiling of these should not be 8. So entrance height minus reveal divided by maple thick plus reveal. And the rounding of that. I mean, we could use floor and then just do like +1 at the end to give us 9, but that doesn't seem like it's the right thing to do. Seems a little backwards. So instead of doing floor, what do we get? We just let it be. It gives us an exact number, so that'll be why. So we do actually have to just do +1. If it didn't give us an exact number, then we'd still have to do this. Okay, so floor of that whole thing. +1 at the end. Okay, so that gives us our 9 slats on the front. So that's looking like a little. That's looking a little kind of weird, kind of Aztec or something. Maybe we will have the slat wall on the back instead. Either way, let's kind of get the dowels in place. We'll do 1, 2, 3, 4. Go with it. And we'll go from there. So let's hide the slat roof because it's in the way, and we will go from this face here because that's in the center of all of our lines. And we'll say that we want to do circle here, and a circle down here, and that circle is going to be a dowel size. And we're going to do a line in the middle as well, a construction line, from this midpoint here to the one at the top. I'm going to align these 2 circles on. This one's oversized, that's fine. We're going to put it on this line here, and we're going to do the same for this one on that line. And then we can actually use an equals constraint to say this circle here should equal this one, and it shrinks it down to the right size. clicking buttons. And then we just need to we need to get 2 more in here as well, but we also need to make sure that we're not going outside of these bounds here. So what we're just going to do is project these 2 lines into the scene. So by kind of angling out to the side, projecting them in, going back to our top view. And that's going to be in the right spot now. So we can do a dimension here from the edge to the edge. We'll say we want that to be the reveal. And do the same up top to that edge. It's going to be reveal. We'll also try this in the inverted style with just the support in the middle. I feel less comfortable about that. I think it'll be kind of, might allow it to twist and rack a little more than we'd like. So we should be cautious with that. Yeah, let's make it a circle here. Let's draw it to the side. And make sure it's not construction. And same here. And these are going to be both equal to each other and equal to this one at the bottom as well. And we're going to drop them onto this line, keep them centered, and then say that they're going to be spaced off of here by the reveal as well. And again, spaced away from this line by the reveal. And then what we should be able to do is an extrusion on at least one of them, this one. Take it down to the bottom. It's going to cut a hole through all of them. So let's actually do that for all of these, all 4. It's going to cut that hole from top to bottom. And the objects it's going to cut are just the slat roof, solid beam, and short slat. And actually, because these are copies of the components, we don't even need to technically really use those ones for them. They're going to cut through the tops, so we do. So that's good. If we just kind of look where the slat roof is appearing, making sure those dowels aren't kind of interfering with each other too much, that's good. Let's hide that slat roof again so we know where we're working. So let's cut those, and we'll actually say it's going to go to this object, and it's also going to go into that object by a little bit extra. So half the thing is apply. Or is it? What do I want to put this in? To that object here, and we're going to go an extra little bit into that material. Okay. Looks good. We have to do like times by 1 inch or something now. Okay. Sometimes my OK button kind of grays out, but if I hit enter, usually it kind of resolves. Let's try that again. Let's save. And just try and do that again. So extrude these 4 little circle guys from where they are to the object at the bottom, object being that, with an extra offset of apply divided by 2, so it goes into it a little bit. And okay, there we go. So if we hide the slat one now, you can see it's going to have, well, let's have a look at what that's done. Objects to cut. So we actually want that to be offset negatively, yeah, into the material, and to cut the material too. Okay, so now when we hide the slat wall, you can see there's little holes for it to made up to. And we can actually do a similar thing up top, where we extrude the dowels initially. So where it's creating the new body there. So we'll have to come back even further a little bit there. Oh, of course. So what we actually need to do is just do a combine operation here on this back wall with the two dowels from inside. So this body and the other dowel. We're going to say we're going to cut in and we're going to keep the dowels, keep tools. Cool. So now when we kind of minimize all this, hide the top wall, hide the slat roof, we have little holes there for it to made into too. So that should kind of help out. Yeah, it's looking a bit chunky though, isn't it? So, just going to hide that roof again on this wall. I'm going to activate this wall though, even though it's hidden, just kind of in the way. And we're going to do a extrusion of this dowel down to the bottom there. It's going to be a new component. Cool. And now when we look at that, it's going to be our front dowel. Then we just copy that across. So just do a copy from here to here, from there to there, and then from there to there, and then from that part to this part up here. And they'll need to be adjusted if we do change the width or anything, but for now they're fine. Let's kind of get this looking how we want it to look as well in terms of appearances. So favorites, well, my appearances, I think I had a oak that I was using. I don't know, I just made like a weird fake plywood last time for this guy, where we had to, copy paste, rotate the plies and everything. So for this time, let's try and just do a maple on that, this, that, and these, then oak on the dowels. And zoom in to get the oak on these dowels. Good. That's looking better than when it was grey. We'll say just kind of like plywood looking things for these parts. It's something. And I think this, we want the grain to go a little better, so we will adjust that accordingly. Just going to close down this so we can work a bit quicker. Texture map controls on these, we don't want to be that far out, we want to be kind of pretty much flat. So I think that's 22.5, looks pretty, maybe it is 25. Okay. Looks pretty good. And then the base as well, that's a little off, should be going in the other direction, 90 degrees twisted. Maybe get a little longer like that. Yeah, that's something. Yeah, I think that's okay. We'll kind of send that over, see what they think. Ultimately, it's not really going to end up in my home, so if they like this, then this is what we'll go for. So we can change some display settings as well. Just do kind of like just shaded. And come into the render view, take a little look at that, what it's going to look like, or at least kind of close to what it's going to look like. We're in a photo studio. Something like that, and then we'd probably also add a screw or two into the sides, just to help. I mean, I like it. I think we could do some good stuff with this. So I'm going to set this rendering. I'm going to take a screenshot as well, send that over, and that's about it. I think for now, though, we're going to call it that for the stream. There's not really much else going on. So thanks for coming by. Thanks for watching. I think I'm going to start adding these onto YouTube as well, just so we have a sort of more permanent record than the 2 weeks Twitch allows. So we will we'll do that. Again, thanks for watching. Thanks for the support. Travel calls my name. Thank you for the new follows. Again, Travel calls my name. Both the YT Dotty, Nuclear Slug, and Satesh from last week. Thank you again. Have a good day, or good evening, I guess, at this point. And I will likely see you again tomorrow. Okay, thanks again. Bye-bye.